Hi, today we're going to conduct experiment 4 under the pressure. Do fill in your names, programs, metric numbers, and the group. We're going to page number 17. Page 17, there is a website that you can click and then it will bring you to this website here. This website contains a tag and also some of the parameters that you can insert. This experiment, we're going to use the P equals to the F divided by A principles. The pressure equals to the force divided by the area. If we have a higher force, it will reflect as a higher pressure. If we have something that's very heavy, it is indirectly means a higher force. That is going to translate into a higher pressure. How about something that's so dense? Let's say we have a honey rather than the water. Honey is very sticky and then is more heavier compared to the water. We have the honey denser means that the force is much higher, then the pressure is much higher too. The first task, we're going to key in some of the value and then we're going to use the setting as the second diagram below. Okay, so now we look at the right hand side here. We need to click the grid, and even though it doesn't click the ruler, so we're going to click the ruler. It's going to help us later on. So we bring to 1 to 1, means that 0 meter to 0 meter. Next is we have the atmosphere on. We want to have the air as our pressure, and then we want to start using the matrix units. After that, the fluid density, we're going to start using the water. So water will equals to 1000 kilogram per meter cube here. And then the gravity will be 9.8, no problem. We're going to fill in the water by loosen the tap here. So now our water is already filled in. We have 0 until 3 meters. What will be our first task? Our first task, we want to determine what is the pressure of the water at 0 meter, 0.5 until 3.0 here for the water case. And after we fill in the water pressure, we're going to change our density into the gasoline, and then we're going to find what is the value starting from 0 meter until 3 meters depth. Then last one will be honey. We're going to change our density here, okay, into the honey. Then we find what is the pressure for 0 until 3 meters. We do one example. We take the water, so the density of the water will be, yes, exactly 1000. So now we have the density representing the water. At 0 depth, we need to have a device to measure what is the pressure. The device will be the meter here, pressure meter. We're going to put it as close as the surface there because surface represents 0 meter. So in order for us to look it tidier, so we could arrange it at a better position starting from right to left. Okay, it will be somewhere here. Okay, how about 0.5? 0.5, there is no scale for 0.5, so we need to use this ruler to help us. 1, 2, 3, 4, 5. It got a total of 5 mini scale, so it will be somewhere here. It will be somewhere here. Okay, and then we want to find what is the pressure when the depth is 1. So 1 here. So later on you do it until the 3 meters and also for the gasoline and the honey. So we use the kilopascal as our units, 101.380.1 0.380 kilopascal, and then at the 0.5 there will be 106.880 kilopascal. This one will be 111.139 kilopascal. Okay, complete this table and then you have finished for the table number 1. Next, we'll go to the discussion. Based on the simulation, based on this experiment, explain the effect of the density to the fluid pressure. Okay, we're going to choose the honey. It's more dense. Okay, once the honey is chosen, you can see that the pressure will slightly change. For this one, 101.403. In theoretical, it won't change because it's on the surface, but maybe uh, our detector accidentally goes into 2 cm, so it contains some of the different weight. So for 0.5 meter is 109.214. When we compare the water versus the honey, we see that the honey having a much higher pressure. Why so? Because the honey contains a higher density. The higher density will reflect as a higher mass. A higher mass will reflect as a higher force. So that's the relationship between the density and the fluid pressure. P, the pressure, equals to the F divided by the A. A is fixed. The area is fixed. Because our detector, the edge of the detector, the area is the same. So F depends on the mass. The mass, that would be what is the weight of the fluid. Weight of the fluid depends on density. Because density defined as the mass divided by the volume. So higher density resulting higher pressure. B. Based on the result, compare the pressure exerted by water, gasoline, and the honey. You choose one of the depth. Let's say I choose 2 meters depth. Who has a higher pressure? Is it water, gasoline, or honey? And then what is the difference between honey and the water, honey and the gasoline? You write it down. We go to the next. If the square container was replaced by a container as below, okay, we're going to replace container as below here. Okay, we're going to choose this one. Discuss the changes in pressure based on the Pascal principle. You see the honey is not fully filled, so we need to open the tap, let it fully filled, and then we compare versus the initial one. We found, you can see that, let's see the 1 meter one. For the 1 meter, 115, 115 is the same. Now we want to explain why the pressure is the same even though we have a different different shape. We want to use the Pascal principle to do the definition. We can go to the website and search what is the Pascal principle, and then we use the statement, the ideas behind the Pascal principle to explain for the different shape case. Pressure applied to a closed fluid will be transmitted without a change in magnitude to every point of the fluid and to the wall of the container. Means that the shape has no influence on the pressure at the standard or at the defined point there. For our case, we define 1 meter. So 1 meter when we are using the normal tank is 115. When we change to a weird shaped tank, it's also 115. Okay, so now we go to the discussion, the effect on water pressure in additional 100 kilogram load were added in the water as shown in the figure below. This is the third diagram. Okay, we'll choose this one. Okay, we miss. Okay, we'll pull the 1 meter just now. Okay, it has a different value compared to the previous because we haven't filled in the water yet. But no worry. So we try to use 1 meter for this special case. Okay, you can write honey at instead of 1 meter. Okay, we'll use this point as our benchmark to see whether that once the load is added, we'll at this point, the benchmark point, we're going to have a higher pressure. So honey at specific point is 105.528 kilopascal without 1000 kilogram load. Now we're going to add the load. 3 loads added, so it's going to produce 1000 kilogram applied to this new tank. Once the load added, the new pressure at same point is 107.130. Okay, discuss why we have the increment of our pressure. So at this specific point, the depth of the liquid, the honey, increase due to the load. Depth resulting higher mass. Higher mass resulting higher force. F equals to the mg, the gravity. So the load does increase the pressure. It will be something like this. So the idea behind, once we have the load added, it's going to shift the depth of the honey will be higher compared to the previous. So once we have the increment of the depth, much more honey on top of the detector point there, we're going to have much more mass at that point. So the mass will reflect as the force, and the force has the relationship to the pressure. We go to the next one. Okay, this is the last table. Table 2 show pressure and density of 6 different fluid in the rectangular container at 2 meter depth. Calculate the density of fluid A, B, C, and then you rank the fluid density from low to high. Okay, now there are total of 6 kind of fluids. We have the water. Okay, the water we can adjust it to 1000. And then we have the gasoline, and then we have the honey. We can use the basic tank, easy for us to do the calculation later on. Okay, ruler is useless at the moment because we have the 2 meter already. So at 2 meter, when it is the water, so it is somewhere like 121.252. It's quite difficult to just the exact point, so we get as best as possible the 2 meter depth level depth. So density is 1000 K, here 1000. And then for the gasoline, we change it to the gasoline. So we have it equals to 115.274. For the honey, so we scroll to the right and it turns into honey. It's 129.621. The next one, we want to have the pressure of 134.9. Okay, we cannot scroll to the right hand anymore. So for this one, just ignore it. When X, no, it's my mistake. Okay, for the B fluid, 117.915. So we're going to adjust and we want to make it into 117. Okay. Okay, we cannot get the exact, so we just take as close as possible. So the density is 833. And the C1, so we're going to scroll to the right hand side to make it denser in order to increase the pressure. 123.05. Okay, there'll be 1090 the density. So we have 5 fluids because we ignore the A. So we want to rank the fluid densities from low is 1. Okay, this will be the lowest. 1, 2, 3, who is 4 and who is 5. Okay, that's all for the this experiment. This will be an experiment about the under the pressure. So complete the experiment. Leader, you coordinate the meeting with your group members so that everybody uh, have some tasks to do and then they can contribute to complete this report. After that, everybody going to fill in for your own and submit in the eCampus. For this one, no need to do the video. Okay, no need to do with the video. Okay, bye bye.